Hello and welcome to today's lecture. So basically, we are going to pass through Hugging Face Tokenizer. It is basically what we are working on through the previous lectures regarding the encoder module. So the tokenizer is doing pretty much the same thing. So I'm going to go overview here within this Bert tokenizer and show you how you can work it in the same way as we have built the encoder module. So let's get started. First, I was importing this Bert tokenizer. You can actually import multiple tokenizers here, like a Bart tokenizer or distilled Bert tokenizer. You can have as much as you can. I will also share the link of all the language models tokenizers that you can use, and it is also like it's a good thing to use this Bert tokenizer with the Bert model and the Bart tokenizer with the Bart model, because each model have pre-trained on some vocabulary that might be different from other models. So you should better be working with them as the same thing. Okay, so now I am here using the pre-trained tokenizer, which will be being, if you are for the first time running this notebook, so you should be showing some downloading bar here to download all the vocab of this tokenizer. It will be pretty much quick, or if it was a Bert model, then, for example, if it is a Bert model itself, for example, for sequence classification, then it will take some time maybe to download the weights of the model. But maybe we can have another lecture for this, but let's now focus on the tokenizer part. Okay, so now I'm reading first head of 10 lines of data, and then I am here working on splitting some review into 4 sentences, which actually it was a long review, so I split it into 4 sentences. So basically, I'm going to encode this tokenizer using some method called the encode. It's pretty much same as we have done through the encoder, so it's not very difficult. Also, some other part, which is the encode plus. So it's a little bit different from what we were having. Basically, it gives 3 outputs: the input IDs, which are pretty much these, the token type IDs, which will be zeros. We'll be talking about this in the next cell, and also the attention mask, which basically giving the model, whether it is a Bert model or anything, or any language model, that we need to attend to these tokens because they are not padding tokens. So the attention mask here is focusing on the non-padding tokens. Okay, and let's see what is the token type IDs. So for example, if I have question answering or some sentences like question answering task, so I have a question and an answer, so I need to give the model some context that this is the question and this is the answer. Okay, so the token type IDs here, if I inserted this, it will be embedding these 2 sentences into the same input IDs, but the token type IDs will be different. It will be first sentence will be in zeros and the answer will be in 1. So the first sentence will be as expected as a different context, and the second sentence will be 1. So if I am importing Bert for question answering, then it will be using these token type IDs. Okay, so while the tokenization within the dataset module that we have discussed earlier, we need to give the token type IDs to the Bert model. Okay, And let's see what is this input types. As you might see here, there exist, for example, here there exist two special tokens that you might be noticing. This 101, 102. Also here there is 101, and the last part is 102. So these actually are some tokens that you might see. Also there exist, if we need to remap this token into their actual tokens, actual string tokens. So there exists this decode. Okay, so actually it is nothing but here you have this CLS token, which is notifying the model that this is a start token, this is the starting point, and this separation, it can be the end of this sentence or maybe the end of the whole tokenized sentence. Okay, so we have two separate tokens here because we have two sentences and we need to separate across them. And also the token type ID gives this different dimensional of this is the question and this is the answer. Okay, so now we have this understanding of what is the encode and encode plus do. So we might do something different, like whether we need to encode a batch. Okay, so let's start batch encode plus. So basically, if we are going to do the batch, we need to apply list of sentences like this. So as you can see here, it will be batching everything, like the input IDs will be a list, a multidimensional list of lists. Each review or each sentence will be tokenized like this. And also the token type IDs, I can also, like, for example, okay, for key value in not item, because it's nothing but a dictionary, right? So key value. I just need to make it a little bit more readable. Okay, that's pretty much easier. So now you can see this input IDs will be a list, two lists, and also the token type IDs will be two lists, and the attention mask will be two lists. Okay, so if we are adding, for example, R3 and R4, we will have multiple lists corresponding to the number of reviews. Okay, a different parameter here, what if we need to add padding? Okay, so padding will have three different types of padding. We have the longest length, we have the max length, and we have the no padding. So the no padding is the default part, like it will be a string called no padding. This is the default. I will be checking this again. Do not pad, sorry, do not pad, and the max length and the longest. Okay, so these are the three types of padding that we can use. Let's put them, for example, here. And check for do not pad. So do not pad is pretty much the same thing or the default behavior of the padding. What if we set the longest? So basically it will be sorting the lengths of these reviews, and it will be doing this, like if I have here, if I need to know the maximum length. Okay, so this will be the maximum length review. It will be, for example, this is the second review. It will have like what is the length of this review. It will be like number of tokens here, like 10 or something. Okay, like 3, 4, 5, 6, 7, 8, 8. It will be 8 tokens. So if I have padding the longest, it will be making every length of these tokens to 8. So if I add enter here, so as you can see, the first review here, what is the most part that shows the padding is the attention mask. As you can see in the attention mask, it was all ones, but here you can see some trailing zeros. These are the padding indices. So here you can see there exists some padding. So the attention mask is telling the model that don't care about these last 4 tokens, only care about these first 8 tokens. Okay, and the same for the second and the same for the third. Like as you can see, only the last sentence will have no tokenization. So this can be a type of padding. And some other part is the max length. So the max length actually, it needs to define a max length, or it can use the default max length. So what is the default max length for any language model, or for the most language models, is 64. So basically we need to we can see here like the length of this vector is 64. Like for example, if I apply the first length of the first attention mask, it will be okay, it's 512. Sorry for that. Most of the language models will be the maximum length will be 512 tokens. Okay, and if I need to make the maximum length a customized part, so I can change the maximum length parameter to example 10. Okay, so as you can see here, there exists 10 only tokens being applied. Okay, so this is the batch include part. I can also use these input IDs to make this, like I can copy paste these parts here, and like this is batch tokens, and I can do tokenizer.batch decode these tokens. So as you can see here, it transformed the zeros into bad, another special token, and the 102 and 101 is the CLS and separation part, and the tokens are being getting back to their original way, but after some pre-processing. As you might see, there exists some lowercase pre-processing had been applied to each sentence. Okay, also some other parts called the truncation, but this by default will be true. Like I can truncate the long sentences, because for example, if some sentences are beyond the 10, for example, if I have here max length of 5, okay, so as you can see here, I'm padding to the max length, and the max length is 5. So why I'm seeing this number of long sentence of 10 tokens? Because I didn't apply truncation. Okay, so truncation should be, if truncation is applied, you will be seeing all of the lengths of the tokens will be the same length. Okay, so these are pretty much most of the attributes that we need to modify while pre-processing our data within the dataset module. Also, we might be using this encode plus part from the batch encode, but I'm just showing you how you can modify this. And by the time we can have another perspective of the different types of the encoders, like the question answering and the multiple sentence. So you can also apply this truncation and make sense in different ways. Okay, I hope you understand today's lecture, and see you next time. Thank you.